Hey guys, so today you and I are going to talk about system design. So let's get into it. So the question in question was, hi Frederick, is software engineering of systems and system design all about making trade-offs? Well, everything is about making trade-offs. I mean, if you eat a candy bar, you're trading the short-term gratification for extra calories. Or if you eat a piece of fruit, you're, I don't know, not drinking water. So, but yes, you can define it like that. If I'm not going to be so philosophical, I'm going to say that system design is all about, I wouldn't say it's all about making trade-offs. It is, as I like to say, it is about making the right decision for the moment with an understanding of what direction things are going to head. And that's where the trade-offs become a part of that thing. As an example, it's sort of like the stock market or like your finances or things like that. So it's very difficult for you to predict how, say, the stock market sometimes is going to work. And some people have lost their entire life savings and things like that because they invested all their money into, like, they have nothing like just in reserve, like sort of locked away in some safe space. They have everything in some type of stock or something like that, and then for some reason that drops and they lose all their money, right? And so the trade-off that they have made is that they maximize their potential gain from maximizing the amount of money they have in stock, so that they can benefit from the market. But the trade-off is that they have no security, or very little, less security than if it's just gold sitting next to them or something like that. And so, but on the other hand, if you don't have anything in the stock market, well, then you can't really reap those sorts of benefits, right? And for software developers and system design, it's sort of the same thing, because when you get a business requirement, it's very difficult for you to predict what's going to be the next thing. So and at the same time, you can't really design a system that is so generic and future-proof that you might never make any mistakes, or that it's just going to perfectly scale into the next thing, because you have no idea, guys, how quickly business requirements can change. You can it's in some extreme cases you might have to like basically scrap an entire project, or like the whole thing just changed overnight virtually. Or more commonly, you invest a lot of money into this big thing, and then the business realizes that, oh, there's this new awesome market thing here that is much more important than the thing that you have been working on, that was like the flavor of the month, most important project ever. We have to have this, otherwise we go under, just a month ago. And then that big project becomes an orphan. Orphan is a term we lovingly use within IT to refer to a project that has been abandoned by everybody. Nobody's maintaining it, and you have no idea how common this is, guys. It is really, really common. You spend tons of time or something on building an API or a service or something like that, and then like a week or a month after it's been shipped, and you sort of maintain it, you just sort of started getting it to function well. Your business representatives come in and say, we need to move all your developers over to this other project that is more important. And you go, okay, but who's going to maintain this? Oh, you should just put 10% on it or 5% on it, which in reality means you're not going to do anything with it. And then you move. And then all the sorry fucks like myself, who depend on that system because we still are working on a feature connected to that, well, let's just say that we don't all get along because we need help, and we don't get any help from the people who are supposed to maintain that orphan. And so, yeah, this is the dark side of office politics and IT, guys. More fights and inter-team disputes are down, than you can possibly imagine, are down to the fact that there is a misalignment in priorities and scheduling and things like that. And it really comes down to this sort of problem, right? And so the trade-offs they're always there when you design a system, because you can't make a perfect system that will be great from all perspectives. This is why I tell people that the one constant that you have to account for is change. Always change. Every single day of the week. And that is why I am a firm believer in an architecture or like a system design that basically, in a sense, I would like to make the analogy to it works as a natural resource. That sort of cadence or like a way of thinking about it has worked really well for me, where the natural resource of software or IT is data. Data, data, data. That's everything. Everything, it's like water. And so when you design a system, you should ideally architect it in such a way that higher level services or things that do some type of business value, in a similar sense, it's like a layered architecture in a single application or a monolith. Constructing your system in a similar sort of fashion is one of, if not the best way to do it, because you don't know if that awesome super feature that you're building right now is going to end up being completely useless in like a month or something like that. So if you invest in an architecture or a design that heavily relies on that thing is maintained over time, or that it's really well taken care of, you're creating this really weird situation where you don't really, you might have to, and this happens all the time, guys, you have like these behemoth systems that like mix and match tons of different functionality, and then you have other systems that do the same sort of thing, and unfortunately they become involuntary owners of the data itself, and all of a sudden higher like downstream systems can't like do basic things like lookups and filters and searching and stuff like that, because there's no central database or there's no way of doing it in an effective manner, because you have all these higher level APIs that are sort of causing an issue for you. And so if you have a lowest level, as I like to say, think of a database with an HTTP interface, the lowest level RESTful API that you can imagine. It's like basically just a server with a few operations on top of the database. You always have the option of fetching data from the river or fetching water from the river, and as long as you can fetch water from the river, you create an architecture that might not always be perfect, but it at the very least doesn't block you from doing the things that you need to be done, because you the raw resources are like always accessible to you. And then the second part comes in, which I think is very important as well. This creates a very loosely coupled architecture or a design which is, as I like to call it, disposable, where you might have this really big behemoth type of thing, or like this awesome feature that does all this stuff, but it's really not useful anymore. And even though it's there and it might be consuming things from the river, or like the data APIs, well, you're probably, even though it might have been nice if that thing kept on growing and becoming something really nice, you can sort of forget about it, because you can build a new system or something different that has different requirements without having to worry about taking allowing the decisions and complexities of that old system to affect the new thing you want to build. Because as long as the data layer of your system is pure, if that makes sense, you're in the most flexible manner. It's sort of, as I said, it's like a natural resource. Though, like if you have a company that owns all the water, then everyone else has to sort of handle whatever decisions that they are making. But if there's like a sharing strategy or something where you actually can just get the water from the river, it might not be as convenient as someone bottling it for you and sending it to your house or something like that, but it's more flexible, if that makes sense. And flexibility is one of the most important things when you're writing software at scale, at least in my opinion. So what I want you to take away from this is that, yes, to a point, system design is about trade-offs. The problem is that everything is about trade-offs, and what I argue that really good system design is all about is to figure out what is going to be the most like the short-term best solution for whatever I'm doing, and how can we make that solution in such a way that it fits into the long-term perspective without coupling it too hard to the current state of things. Because, as I said, if you only think about the long term, you're going to build like an enormously complicated system that might never see the light of day. So you have to think about small scale things. Like there's a very nice saying that the next, like, a big apps and stuff like that. If you're going to build something for people in the startup world, you ideally want a product that is useful at small scale, but also useful at large scale. Because it's like a social media platform, the problem with those sorts of systems is usually that you have to have millions and millions of users before you get a sustainable business model, usually. And that is a problem, because you want it to work at small scale and at large scale. Same thing with system designs. And that's why it's very important for you to understand that the trade-offs that you are making is usually, you might not be able to make a perfect architecture at any given time, but the thing that you should always opt for, if at least in my opinion, is to make sure that you never create a situation where changes in requirements, changes in the ecosystem, changes in the business model or whatever has a destructive effect on your current system. Because it's usually easier when a new set of requirements come in to start over, to just go back to basics and create a new system on top of the data that you have within the system, as opposed to trying to endlessly fit it into the same system. Because you can do that for a little while, but sooner or later that super system that you started, that architecture that you created, is not going to reflect the business model anymore. And if you're locked into that thing, yeah, that's not fun for anybody. Have a great day.